Hello, everybody. This is Mr. Walker. Our topic for today is using multiplication facts to solve division problems. Today, we're going to be doing problems that have remainders, but also one or two without remainders, and we're moving up to three-digit problems. By the end of this video, you will be able to use multiplication facts to solve division problems with up to three-digit dividends with and without remainders. Now, by three-digit dividends, we're talking about our dividend here of 429 is a three-digit number. 429 divided by 5 equals, I'm going to go digit by digit. 5 does not go into 4, but 5 would go into 42. I'm going to draw a line here just to kind of show that. And I'm going to use my division facts here to create a multiplication fact. So 5 times n. And I'm going to narrow it. The reason why I made the line here is I'm not going to take the whole three digits, but just the 42. Using a multiplication chart, I'm going to go to my 5, and I'm going to look for 42. I don't see it here. So the rule there is that if you don't see 42, in this case 42, you can get as close as you can without going over. That would be 40. So that's going to be 5 times 8. So we're solving for n, that would be 8, but it doesn't equal 42. The closest we could get was 40. Now, both of these numbers I'm going to ask you to circle because we want to use both numbers. The 8 I'm going to go right there, and the 40, notice that when we compare, 42 and 40 are not the same numbers. They're different numbers. And in math, different or difference means that we're going to subtract to find out how much is our difference. Well, 2 subtract 0 would be 2, and 4 minus 4 is 0, but I'm not going to write the 0. Now, we still have the 9 here. What I'm going to do is bring that down, and I have 29 written down here. Well, I'm going to do the same thing I did up here, but except I'm going to use it for 29. 5 times n is equal to 29. Once again, if I just use my chart to show you that, 5 times anything does not equal 29. So I want to get as close as I can without going over, which would be 25. So remember, that's going to be what? 1, 2, 3, 4, 5. So 5 times 5 does not equal 29. It actually equals 25. I'm going to cross that out. Circle both. I'm going to use both numbers. The 5 now goes right here. The 25 goes down here below the 29, and I want to compare. Notice that they're not the same numbers. They're different numbers, and in math, difference means you subtract. 9 minus 5 is 4, so my answer is 85 with a remainder of 4. For some vocabulary, remember we're using long division, and they would refer to this box, or sometimes the box has this curve, as a long division symbol. Sometimes it's referred to as a division bracket. I like to call it division box. Our vocabulary for these kind of problems, the number inside the box that we're dividing up, the large number, is called the dividend. The number of equal groups we're looking for, which in this case is 5, is called the divisor. And the answer in this case, which is 85 remainder 4, is called the quotient. And for purposes of our lesson, again, in fourth grade math, we want to make sure you know quotient. It's good to know these terms, but really make sure of the three that you know that one. And we would read this problem in a clockwise motion, starting with our dividend. 429 divided by 5 is equal to 85 remainder 4. Please keep in mind that doing these kind of problems, that place value, is important. And when I'm talking about place value, I'm talking about the place value of our dividend. Look here, 429 is our dividend. And I put our place values up here, hundreds, tens, and ones. If I were to extend those columns down, you'll notice that the 429, the 9 is in the ones, the 2 is in the tens, and the 4 is in the hundreds. So in this case, when we're putting the 8, it's not 8 ones, it's actually 8 groups of tens because we're working across to solve division. This 5 here, you'll notice, is in the ones. Remember that our key ideas is that division is the idea of equal groups or fair share, that division and multiplication are called inverse operations, which means the opposite. Sometimes you have remainders, but sometimes you do not, so keep that in mind. And for solving problems like this, I like to say that it is a digit by digit of our dividend, and I'll show you what I mean in just a second. I wrote the word dollars here as a reminder to share with you that when you solve problems like this, try to make it into something that is real, that you understand. For example, 213 divided by 4, but if you think of it as $213 divided by 4 people, it helps you visualize it a little bit better. Okay, 213 divided by 4. I said about going digit by digit, so I take a quick look and I can see that 4 will not go into the 2. So then I expand that to 21, and 4 will go into 21. I'm going to draw a line here just as a visual reminder that we're focusing on the 21. Now I'm going to write a multiplication fact using 21 and 4. So I take the 4 times n is equal to 21. And I want to use my knowledge of multiplication to solve that. I'm not going to use a chart for time's sake, but the closest I can get to 21 would be 4 times 5. But 4 times 5 equals 20. It does not equal 21. The closest I can get without going over would be 20. I want to use both of these numbers. The 5 comes up right over here, right? The 20 goes down here. Notice they're not the same. 21 and 20 are different, and in math, different means difference, which means we subtract. Now, what are we going to do with this 3? We're going to bring it down and create 13. Now what we have is 13 divided by 4. And once again, I'm going to create a multiplication sentence to solve. I know that 4 times 3 is equal to 12. Notice that it's not equal to 13. I'm going to cross 13 out. The closest we can get without going over would be 12. I'm going to use both of these numbers. The 3 goes up here, and the 12 goes right there. Notice that 13 and 12 are not the same. It means we're going to have a remainder. 3 take away 2 is 1, and so that goes up here. So our answer is 53 remainder of 1. Or in other words, our quotient is 53 with a remainder of 1. solve. 834 divided by 9. I'm going to go digit by digit. 9 does not go into 8, but it does go into 83. I'm going to just draw that line there to show that I'm focusing on the 83. And now I'm going to create a multiplication equation. 9 times n. Remember that n is our unknown. We don't know what this number is, and that's what we mean by n. They call that a variable. Is equal to 83. And again, you can use your multiplication chart. I'll use it for this one. So we go with 9. And I'm looking for 83. Now I know we're not going to find it. It's not here. But the closest I can get is 81 without going over. So that would be 9 times 9. But 9 times 9 is not 83. It's actually 81, but that's okay. We're going to use how many of these? Just that one? No, we're going to use both. So 9 goes up here above the 3, and our 81 are these numbers the same, 83 and 81? No, they're different, so we have to subtract to find out how much different. 3 minus 1 is 2. Are we done? No, we still have this 4. So we're going to bring that down. And now what I have left over is 24 divided by 9. And I can use my multiplication to solve that. 9 times n is equal 24. Well, my knowledge of multiplication, I know that 9 times any number does not equal 24. But I do know that 9 times 2 is equal to 18. That's as close as I can get without going over. So it does not equal 24. It actually equals 18, but that's okay. So now we're going to use both of these numbers. Where does the 2 go? Right, it goes right up here. And our 18, again, look at that. They're not the same, right? And if they're not the same, it means they are different. In math, difference means subtract. And if you work through your steps, you're going to get 6. Notice that 9 does not go into 6, okay? So the 6 is our remainder. So our quotient is 92 with a remainder of 6. You can pause if you like. Here's an example without a remainder. I told you there'd be one without a remainder. 135 divided by 5. I know that 5 does not go into 1, but I know it will go into 13. So I'm going to draw that line just as a reminder that we're working with the 13. We're going to go 5, right, times n is equal to 13. Well, we know that 5 times any number will not equal 13. But I do know that 5 times 2 equals 10, which is as close as we can get to 13 without going over. So it's not 13. It's going to be 10, but that's okay. We're going to use both numbers. The 2 goes on top, and the 10. You want to ask yourself, are these two numbers the same? And they're clearly not. They're different, and we have to find what is the difference. Well, the difference is 3. When we subtract, bring down the 5. And what we have now is 35 down here divided by 5. Well, we can use our multiplication again. Is equal to 35. And in this case, let me show you. I'm kind of excited. We actually have a match now. Watch here. 5. And here's 35. Yeah, so this time, if I count down 1, 2, 3, 4, 5, 6, 7. And guess what? That equals 35. So I can use this. Like always, I'm going to use both numbers, 7 and the 35. But this time, notice that 35 and 35 are exactly the same. And what that means is that we do not have a remainder. So 135 divided by 5 equals 27. One more, let's try a word problem. Ben, Sam, Caleb, and Faith earned $367 doing chores for Grandma and Pop over the summer. They decide to share the money evenly. How much money did each person earn? Okay, so let's see. It says that they earned $367, so that's important, probably. It says doing chores for Grandma and Pop over the summer. They decide to share, that's a clue right there, and I see the word evenly. Remember we said that division is fair share. How much did each person earn when they shared that? Notice that I have the total. So whenever we have even or each or sharing it evenly, it's either going to be multiplication or division. In this case, it's going to be division because we already have the total amount. And division is when you take a total and cut it up into pieces. Now the problem is how many pieces? I don't see another number. But what I do see is people. I see Ben, Sam is the second person, Caleb is the third, and Faith. So I'm counting that there are a total of 4 people for this problem. Now I'm ready to write my division problem. 367 is my dividend, and my divisor is 4. I know that 4, we go digit by digit. 4 does not go into 3, but it does definitely go into 36. So I'm going to use this information to write my multiplication fact. 4 times n, which is our unknown number, is equal to 36. Well, I do know that this will go in exactly, and I'll real quickly show you that. Look at our 4, and there's 36, and notice that would be 9. So 4 times 9 is 36. So I circle both and use both numbers. 9 goes up here, and 36 right there, okay? They are exactly the same, which means that there's no remainder, but we still have this 7. The 7 comes down, and now my problem is 7 divided by 4. Well, I'm going to use the same idea here. 4 times n is equal to 7. Well, I know that 4 times any number will never equal 7. So I have to get as close as I can without going over. Well, that's just going to be 1. 4 times 1 is equal to 4, not 7. So it's not 7, but it equals 4. I'm going to circle both like always, and I'm going to use both. And then this 4 goes underneath the 7. Well, I can tell that 7 and 4 are not the same. They're different. And when I subtract, I get a 3. So my number left over, or in other words, my remainder is 91 with a remainder of 3. So how much money did each person earn? It looks to me like each person earned $91. However, there were $3 that were left over that maybe they can, buy some candy and share that or something like that. So, okay. So in quick review, I can find my first page here. Our lesson today was using a strategy of multiplication equations to solve division, but this time today we were going with larger problems, 3-digit, and we said that it was important to go digit by digit. And notice that we're working from left to right and that we create our multiplication facts. We use both numbers and then we have to find the difference by subtracting, and that sometimes there are remainders and sometimes there are not. Okay, thanks a lot, everybody.